Hi everyone, and welcome to our channel. In this episode, I'm going to show you how I created a baseball. Now, not just a baseball, because that's rather easy, but one that could be used over and over again. For example, I created this design and carved it out as a tabletop for my wife. She's a big fan of the Philadelphia Phillies, and I wanted to put a baseball in each of the four corners. I didn't want to have the same baseball look in each corner, but I wanted each one to represent a different type of pitch. A fastball, a slider, a curveball, each one in a different corner. But that meant that the stitching on the baseball would have to be different. So I wondered if there was a way to use one baseball and just move the stitching around to replicate what an actual baseball pitcher would use. So let's take a look and see how I did this. I opened up my session of Aspire and I created a file that was close to the size of what an actual baseball was. I did a little research and found out that all baseballs are not the same. So I started with a 3" by 3" because the baseball dimensions could range between 2 7/8 to 3". I chose a 2 31/32. I don't know why. Sounded like a good number. I try to make sure that when I create components and models, I utilize all the pixels within my workspace. I didn't want to create a 3" baseball in a 4" by 4" workspace. And it was simply drawing a circle and creating a component that was half the baseball. Pretty easy. I think if you've been following me along in these lessons, you should have no problem creating this. I then imported a picture of the stitching. I found this on the internet, and it's a rather rough example of what the stitching might look like. I enlarged the picture so it was close to what I thought it might be and positioned it as I felt it was right. I then used the trace bitmap to create the vectors of that image. Again, there's nothing unique about this so far. I deleted the image, and I chose the vectors that were created. And from there, I created a component from those vectors. Sort of a rounded look, because I think the threading or the stitching sort of is rounded. I don't think it's pyramid or flat. And I always check in the 3D view to see how it looks. When I have the stitching where I want it to be, I select the circle and then the component of the stitching, and I keep everything inside of that circle. So it looks okay, except you can see on the edges where it sort of slopes down towards the bottom of the ball, the stitching starts to disappear. Remember what I mentioned? I wanted to create a baseball that I can use over and over again to replicate how different types of pitches are held in the hand of the pitcher. We changed the color of each component simply because it's interesting. White for the baseball leather itself and red for the stitching. I know eventually I'm going to need to flatten this down because certainly I'm not going to be cutting this out of 3" material. But this is how you would start to create and replicate a baseball. But remember what I said. I want to have different baseballs. A slider, a curveball, and you can see from this image, the stitching is in different locations. So does this mean I need to recreate this baseball each time? I hope not. Let's look at it with some other options. If I take my baseball and I export it with an inverted front and triangulate it, you can see that the stitching is now on both sides. Now it's okay looking, but it's not actually what a baseball would look like. So I don't think that this method of recreating a real 3D full round baseball would be acceptable for the end purposes of what I'm trying to do. While I'm here in the export, you can change its quality by saying you want the number of triangles or the tolerance. The larger the tolerance, the bigger the triangles. The smaller the tolerance, the smaller the triangles, and the better end result of an STL that you saved. But again, in this case, it's not acceptable because the stitching is not correct. So let's try a different approach. It's going to be a two-sided cutting. Maybe this will work. I'm going to use the same job setup, 3 inches by 3 inches. Draw the same circle. Create the same component. Sometimes when I'm creating components, I'll go through different options just to make sure that I haven't missed something along the way. You never know. Some things may fall into place very easily using a very specific technique. I import my image again of the stitches, drag one corner out after I've double-clicked on the image, and now I relocate it so it looks more as if the stitching is coming up from the right-hand side. I'm thinking this may be better. I really won't know until I finish. So I use the trace bitmap again, create the vectors for the stitching, delete the image, and use those new stitching vectors. Mirror them to the left-hand side. I think it looks like a baseball. Select all the vectors for the stitching. Create my component again of that. Let's try something with a triangular shape. We can take a look at it and rotate it around slightly. It looks okay, I think. And if I get the stitching to the right height, I would do the same as I did previously. Select the component of the stitches, select the circle, and keep everything within that circle. So it's getting better, but I really don't want to have to keep redrawing this baseball over and over and over again. Again, we go back to the aspect of changing the component color, just for the visual effect. I then made a model of these two components. And I copied it to the opposite side. And when I rotate it, and click on my icon to show both sides, I could see there's the other side of the baseball. But if you look at it closely, it still is distorted and the stitches don't line up correctly.
So, another disappointing approach.
So let's try this one more time. I open a session of Aspire. Unfortunately, this can't be done in VCarve because we're actually creating components. So in Aspire, I'm going to choose the rotary option. Don't worry, we're not actually going to be cutting this out on the rotary. So we have the option of at least using the rotary properties and benefits of the rotary in the designing aspect. I have my vectors that I'm going to be creating a 2-rail sweep. 2 horizontal lines with my half-domed shape. And I create my component. I then create the vectors for where the stitching is. I found it online of the actual size and dimensions of how the stitching template is made. And I simply traced it. Here's a picture from the patent of the baseball of how the cover actually fits together. So with that information, I selected the vector, created an offset twice, and I selected 2 of the vectors and I created a small component, one for the inner stitching and one for the outer stitching. It's that little bump where the stitching goes through the leather of the ball. To show the process of the offset, I select the first vector and choose the offset icon. You choose the distance. I chose to offset it both ways, inward and out. I then selected the 2 outer vectors and created a component from that, a simple rounded component, nothing special. Next, I chose the 2 inner vectors, the center one obviously, and the inner vector, and created another component. And that created the little raised area for the stitching. It's rather simple. Use the tools within the software, and you can create a lot of different things. This is what it looks like. For the stitches, we obviously have our vectors for the placement of the stitches, but I simply drew very, very small ovals, pointed end ovals, to look like a stitch. I chose the icon to copy along a vector. In this case, to show you what not to do, I selected the path first and then the stitch. I then chose to copy it along that path. Well, big mistake. That was not what was supposed to happen. It was supposed to be the opposite. So, lesson learned. I delete that, Control Z. I first click on the icon to copy along vectors and I read the instructions.
select the object first you want to copy along the path, and then say how many you want. A traditional baseball has 218 stitches. I tried that first, but it looks a little bit too tight, too close together. So I took some artistic liberties. And instead of a specific number of stitches, I chose to offset them by a specific amount. 0.122. Hit apply. That looks a little nicer, in my mind. I know it's not authentic, but I think it will generate a better looking baseball than if I did it authentically. I did the outer stitches as well, and that's the end result. So using the tools within the software is important. Learning them and applying them to the models that you want to make becomes important.
The outside stitching and the inside stitching. And I selected those vectors and created a shape, a component, to replicate the stitch itself. I know what you're thinking. It certainly doesn't look like a baseball. But don't forget, this is a rotary project. I then wanted to add a bit of texture. So I found an image of leather on the internet, and from that image I made a component and applied it to my base shape, the half round, just so it's not so slick and smooth. If I then click on the icon to look at the rotary view of it, we now have a baseball that replicates an actual ball much closer than my previous attempts. I think we're getting closer to my end result. With this in mind and this created, I'm going to export it as an STL file. Take a look at it. Looks pretty good to me. Once I've saved it to a good location, I can open a new session of Aspire, a single-sided session, as if I'm going to be creating my final design, and I re-import my baseball. Now, I have to position it the way I want to. First I would do, obviously, is size it down to make sure it's the right dimension, and then position it. I can choose my model rotation, the X, Y, or Z, and drag it around so that the stitching is in the right location. Remember, I wanted to be able to do a fastball, and a curveball, and a slider, or something else, and make sure that the stitching is in its right position. So it looked authentic. If you use this method, you don't have to redraw or recreate that baseball each time. Would it make a difference if the baseball in my original design was all the same? I'm not sure, but I think that there are enough experts out there that would know the difference, or at least appreciate the fact that each baseball was different. During the import process, I can change its Z height as required. And there's our baseball. Add a little shadow shading just to accentuate the model. And then we can compare it with the other pitches that we've seen. A 4-seamed fastball, a 2-seamed fastball, they're all different. That's what I was hoping to achieve. So in the end, using the rotary aspect, the rotary approach, and creating an STL from that model was the answer. I hope you learned a little bit. I hope you can try some of these little tricks that I offer, and I'd love to see what you're working on.
If you'd like to learn more about the software, subscribe to our channel, and don't forget to click on the bell to be reminded of our new videos. And of course, as always, if you need help, send me an email, mm@mezalick.com. I'll be glad to help. Thanks for watching, See you next time. Enjoy.